So pretty much everyone is telling you we're on the fast track to AGI, right? The story goes that if we just make these models bigger, feed them more data, and throw a mountain of GPUs at the problem, we're going to create a super intelligence. I mean, that's the central belief driving a multi-trillion-dollar industry. But not everyone agrees. In fact, one of the most respected minds in the entire field, a guy who literally won the Nobel Prize of Computing for his work on AI, says that whole idea is just wrong. Yann LeCun believes this generative AI craze, the very thing that powers ChatGPT and all its rivals, is actually a dead end. And just think about that for a second. If he's right, the implications are absolutely staggering. It would mean the entire approach that is the whole world buzzing might be built on a flawed foundation. So today, we're going to break down LeCun's argument and his totally different vision for the future of intelligence. Okay, to really get LeCun's beef with today's AI, you've got to pop the hood and see how these things actually work. It all boils down to one single, really powerful, but maybe really limited idea.
The fancy technical term is auto-regressive. I know, it sounds complicated, but the concept is actually pretty simple. All it means is that these models spit out their answers one word at a time, and each new word is just a statistical guess based on all the words that came right before it.
The best way to think about it is like a super-powered version of your phone's autocomplete. You know, the model sees the sky is, and it runs the numbers, calculating that the most probable word to come next, based on a bazillion examples from the internet, is blue. And this is the crucial part. When you ask a large language model a complex physics question, it isn't thinking about gravity or mass. It's not reasoning from the ground up. It's just predicting the most statistically likely string of words that would follow your question, based on all the physics textbooks it's basically memorized. It's a master of probability, not necessarily logic. Now, for short sentences, this works great, but it starts to fall apart when you need complex, multi-step reasoning. Why? Well, because even a teeny tiny 1% chance of picking a slightly wrong word can compound. Over a long answer, these little errors build on each other, and the whole train of thought just goes off the rails. It's like a game of telephone, and by the end, the model isn't reasoning anymore, it's just making stuff up, or as we call it, hallucinating. So if just predicting the next word is a dead end, what's the alternative? This is where LeCun proposes a completely different approach, something he calls a world model. And it's based on how you, me, and even animals actually learn to get around in the real world. Let me give you an analogy to make this crystal clear. Imagine you're driving your car on a rainy day. You're constantly predicting the future to stay safe, right? But you're not trying to predict the exact path of every single raindrop hitting your windshield. I mean, that would be completely impossible. And this shows the difference perfectly. A generative model, the ChatGPT way, tries to predict every single pixel, every raindrop, every leaf on a tree. It's computationally insane. A world model, on the other hand, just ignores all that noise. It focuses only on what's important. If I turn the steering wheel, the car is going to go left. If I slam on the brakes, the car will stop. You see, the goal here isn't to generate a perfect photorealistic picture of the world. It's to build an internal, predictive simulation of it. It's all about understanding the underlying rules of cause and effect, the basic physics of the world, so it can figure out what's going to happen next based on what it might do. So this brings us to the actual architecture that Meta is building to make this whole thing a reality. It's called JEPA, and its learning process is designed to mimic how babies learn about the world, just by watching and forming abstract ideas. The secret sauce behind JEPA is this idea called abstract prediction. So unlike ChatGPT, which is obsessed with predicting the next literal word, or a video AI like Sora that tries to predict the next bunch of pixels, JEPA learns to predict what's going to happen next in a more abstract, conceptual way. So here's a great example of how it works. Imagine the AI sees the first half of a video of a dog jumping for a frisbee. A generative model would try to paint a perfect picture of the second half, trying to guess every single hair on the dog's tail. JEPA, it doesn't care about that at all. It just predicts the abstract idea: the dog is going to keep moving upwards. By intentionally ignoring all that noisy, irrelevant detail, the model can actually focus on learning the fundamental rules of how the world behaves. And this makes the whole learning process thousands of times more efficient. It leads to a much deeper, more real understanding of reality. Okay, so why does this super technical difference actually matter to you? Well, because it represents a huge shift in what we can ask an AI to do. We're talking about moving from just simple content generation to complex, goal-oriented action. Let's break it down. Generative AI is awesome at generating content. Make me an image or write me an email. But objective-driven AI is designed for planning and reasoning. It's the difference between asking an AI to make this versus asking it to plan this. And right now, generative models are fundamentally terrible at planning over many steps without just getting lost. This is LeCun's ultimate vision, to build autonomous agents. An AI that you can give a really complex goal to, like, hey, book me a flight to Tokyo for next week. The agent would then be able to break that down into steps, anticipate problems like your credit card failing, plan for what to do if that happens, and then just execute the whole thing.
And really, this is the bottom line. You simply cannot build that kind of reliable, autonomous agent by just playing a guessing game of what the next word in a sentence should be. You need an AI that has a genuine internal model of the world and can truly understand the consequences of its actions within that model.
So this all brings us back to the great debate that's raging at the heart of the AI industry right now. It's a debate that has some pretty profound implications for the future of technology and, well, all of us.
So is LeCun right? Are we just scaling up a flawed idea? Or will just raw computing power and more data eventually be enough to get past the limits of today's models? It's really a battle between two big philosophies, scale versus architecture. The big bet is on whether we just need a much bigger engine or if we need a fundamentally better blueprint. So what do you think?